Division 2, topic, function and graph, and limit and continuity. Question number 1. Determine the composite function f of f and state the values of x for which f of f is not defined. Okay, there's 2 questions to answer from this one. The first question is to determine the composite of f of f. Okay, and the second question is to state the values of x for which f of s will not be defined. We are referring to our function fx. So, in order for us to find the composite of f of f, so given fx is 5x over with x minus 3. So f of f function means we substitute function fx into fx. So f of f. So substitute fx, that is 5x over with x minus 3 into fx function itself. Okay, taking this function, substitute into the fx, the original fx. Okay, so into the x term lah. We shall end up having 5 of 5x over with x minus 3 over with, okay, now substitute x as 5x over with x minus 3 minus 3. Okay, so later on we just need to simplify this function lah. So you could make the denominator the same. As for the above part, you will end up having 25x over with x minus 3, everything over with 5x minus 3 times with x minus 3 over with x minus 3. Later on, we can cancel off the x minus 3 and x minus 3 there. Okay, so we could cancel off this and this, and simplifying the numerator part for both, which we will end up having 25x over with, okay, multiply this, so 5x minus 3x plus 9, and end up having as 25x over with 2x plus 9. Okay, so this should be our function of fx. So the first question is being answered. Okay, so f of f function, okay, all of the above answer. Now looking at the second part of the question, determine the value of x for which f of f is not defined. Okay, looking into the original function itself, function f, okay, function f cannot take the value of x equals to 3. So the composite of f, looking into the function of f of f, this f of f function cannot take the value of x when it's equals to negative 9 over 2. Whatever value of x that will make the function undefined. Okay, so this particular x cannot be equals to negative 9 over 2. This is of f, but we must remember the original function fx, it also cannot take the value of 3. So automatically both 3 and negative 9 over 2 must be taken out. This 2 value of x is the values of x that will make the function undefined. So for f of f to be undefined, so f of f is not defined for x equals to 3 and x equals to negative 9 over 2. So the answer should be this. Okay. Now, moving on to question number 2. Okay, we are given two functions, function of g and function of h. And we need to identify function fx. given f of g of h is equals to x squared over x squared plus 1. Okay, so this is also another composite function. So given gx equals to set x and hx equals to 1 over x to the power of 4, find f. Okay, such that f of g of h of x is x squared over with x squared plus 1. So what can we do now? So we substitute one into another lah from our function f of g of h. Of g of h is equals to function h into function g, and then the result will be into function of f. Okay, so g of h x. So function hx is 1 over x to the power of 4. Okay, now our hx into our gx. Okay, our hx into our gx, which will be hx into gx, which is into set x, into set of 1 over x to the power of 4. So the result of this now into the function of f, which we don't know lah. That's what we would like to find. I'm sorry. Okay, simplifying this, we will end up having f of 1 over x squared. Now we have our f of g of f. See, this is our f of g of h. Okay, this is our f of g of h, which is now equivalent to f of 1 over x squared. Okay, what can we do? We can equate the two lah. Okay, we can equate the two. Having, therefore, we will have f of 1 over x squared, which will be equals to x squared over with x squared plus 1. Okay, one way to solve this is to let. What can we do? So we can let u equals to 1 over x squared. Okay. Now, having our x squared as the subject, so it will be 1 over u. So what can we do now? We substitute our x squared with a 1 over u. Okay, we substitute that with 1 over u. Okay, and ending up having, so now everything will be in terms of u. So it will be 1 over u over with 1 over u plus 1. Okay, so simplifying this, making the denominator the same for both of the terms of the denominator, and cancelling u and u, simplifying, we shall end up having f of u as 1 over 1 plus u. Now, finally, to answer our question that wants us to find the function of fx is 1 over 1 plus x. Okay? And the next question is to state the domain of our fx. So, obviously, our x cannot take the value of negative 1. Therefore, the domain of f will be all real number except 1 or we could write it in interval form of negative infinity to negative 1 union with negative 1 infinity. So now looking at the answer, it is of this answer here itself. Okay, we shall move to question number 3 now. Okay, question number 3. Function f and g are defined for all real numbers. Find the values of x such that f of g of x plus 3 of g of f is equals to 14. Okay, so the given function of f and g as this. So, taking down the composite given here, so f of g of x plus 3 of g of f of x should be equal to 14. So f of g of x means plus 3 of g of f. So you just substitute individually lah. Here substitute our gx into this, and then substitute our fx into here. Okay, and by rewriting that, we shall end up having x minus 2 plus 3 of g of f. Okay, now having our x minus 2 into our fx. Okay, so we shall end up having x minus 2 into x square plus 2. So x minus 2 square plus 2. And having our x square plus 2 into our gx, that is x minus 2. So we shall have 3 of x square plus 2 minus 2. Okay, or you could put a bracket to it, no problem. Without bracket also is accepted. Equals to 14. Now let us simplify all of the above, and we shall end up having okay. Minus 2 square, bring over the 2 to the right hand side, plus, okay, and then cancelling off the 2 and 2 here. Okay, okay, so plus 3 of x square equals to 12. Now simplify this, x minus 4x plus 4 plus 3x square equals to 12, and finally having it as 4x square minus 4x minus 8 equals to 0. So factorizing this into a simpler quadratic of square minus x minus 2, which later can be factorized into 2 linear of x plus 1 and x minus 2, and finally having our answer of x as negative 1 and x as 2. So the answer should be this. Okay, so continue discussing number 4 now. Find the set of values of x for which fx is less than gx. So our fx function are modulus of 3x minus 2, which should be less than our gx, that is x plus 4. Still remember how to define a modulus function. When we are to define modulus of x less than a, then we should have x less than a and x more than negative a. Okay, so now coming back to our question, we should have 3x minus 2 less than x plus 4 and 3x minus 2 more than negative of x plus 4. Okay, so we shall do one by one. Okay, for case 1, we shall end up having 2x less than 6 and therefore x will be less than 3. As for case 2, we shall end up having 3x plus x, which should be 4x. 4x, which should be more than negative 2. Finally, having x more than negative 1 over 2. Now, what must we do? Is we need to combine both case 1 and case 2. Okay. Negative 1 over 2 and 3. As for case 1, it should be less than 3. And as for case 2, it is greater than negative half. Referring to the original question, it is of less than. If it's less than, then you have to go for the intersection between the two cases. Okay, this is case 1, this is case 2. So go for intersection. So the answer should be in between negative half to 3, not including. Okay, we shall continue with number 5 to find the inverse of the function given here. So by using the property of inverse, that is f of f inverse of x equals to x. So we need to substitute our inverse of f into our fx function. Okay, so this particular x ni, we substitute with inverse of x. Okay, so we shall have 1 over 2 of e f inverse minus 4e negative f inverse, and not to forget to write equal to x. Okay, sorry for the delay. Wait now. Okay, not to forget to equal it to x as it takes the properties. Okay, so now by simplifying, we could multiply 2 to the other side, so you will end up having e f inverse of x minus 4e negative f inverse of x equals to 2x. Okay, one simpler way to solve this is for us to let y equals to f inverse of x, so that now if once we have substitute, we'll end up having ey minus 4e negative y equals to 2x. And in order for us to get the quadratic of exponential function, we multiply e to the power of y to the equation above, which we will end up having e to y minus 4 equals to 2x ey. Okay, now bring over everything to the left hand side, so we end up having a quadratic of exponential, that is e to y minus 2x ey minus 4 equals to 0. As for this equation here, we cannot factorize it into two linear expressions, so we shall use the formula of quadratic. Still remember the quadratic formula?
Okay, let me rewrite the quadratic formula of ax squared plus bx plus c equals to 0. So x will be negative b plus minus b squared minus 4ac over with 2a. So for our case here, identify our a value, which our a will be equals to 1. Our b is negative 2x, and as our c, 1, negative 2x, and c as negative 4. So substitute this into the quadratic formula of ey. So we will end up having ey equals to negative of negative 2x plus minus root of negative 2x squared minus 4 times 1 times with the negative 4 over everything with 2 times a, which is 1 lah, obviously. Okay, so simplifying this part here, we end up having 2x plus minus 4x squared plus 16 over 2. And we could factor out. Okay. So as for here, we could factor out the 2. Okay, ey equals to 2x. Okay. Plus minus, as for this part over here, we shall have it as factor out 4. Okay. 4 of x squared plus 4. Okay, so these are equivalent to square root 4, 2 of third of x squared plus 4. Okay, so we shall have the 2 here. Okay, of, or that particular 2 also can be taken out lah. Okay, so here without factorizing, or I could just simply factor out right away lah. So tadi punya 2 tu aku tak payah factor lagi lah, takut tak perasan kan. So tak apa, never mind, we shall leave it like that. Okay, x squared plus 4 over with 2. Now dah boleh nampak jelas lah. Okay, so semua faktor keluar 2. So you should end up having 2x plus minus x squared plus 4 over with 2, cancelling this, simplifying and having EYS x plus minus third of square plus 4. So finally, since we know that E of y is always positive, therefore our EY should take only the positive part lah. Okay, oh sorry, x, okay betul. Finally, having our y as the subject, lonkan kiri, lonkan kanan. So ln EY ln x plus third square plus 4. Bring over the ln to the right hand side, to the front, sorry. Should be ln of x plus square plus 4. And we have let just now that y as our F inverse, right? So finally, concluding, answering, therefore, F inverse of x is ln of x plus sec of x squared plus 4. Okay, therefore the answer should be this one. Okay.
Number 6. Evaluate limit this function as x approaches 0. So this is actually exponential function. For this part, you may change to 1 over e power x. This one 1 over e power 2x. So let's simplify this one first. Okay, and then e to x minus 1 over ex over e to the power 4x minus 1 over e power 2x. The next step, okay, equating the denominator, okay, e to x minus 1 over ex. Now multiply ex, okay, and over this line, okay, and e power 4x minus 1 over e power 2x, and here is multiply 2. Okay, and then next step, okay, simplify this one, e power this one, x plus 2x equal to 3x. And 3x, and this is minus 1, okay, over ex times e power 2x over, okay, this part 2x plus 4x, indices. So e power 6x minus 1. Okay, in this one, I'm using this concept a over b over c over d is equal to a over b times d over c. This is a over b over c over d. This is a over b, d over c. Okay, and simplify this part is equal to, okay, this one, okay, 2x. So simplify, get x e power x, and okay, e power x, I write down e 3x minus 1, so it is e power x over e power 6x minus 1. Okay, so here actually this one, okay, this one can be categorized. Let's say if you have problem, let this one, let y is equal to e power 3x. Okay, e power 3x. So that this is e power 3x squared. Then you can change all to this one to variable y. Okay, so this one e power x, actually 1. Okay, y minus 1. So is e power 6x equal to e power 3x. So y squared minus 1. If I factorize this one, y minus 1, y plus 1. So this one can be cancelled. Now you get that one is equal to e power x over y plus 1, or e power x over e power 3x plus 1. So we take this one and substitute, replace here. Okay, this one replace to here. Now we're going to find limit as x approaches 0. limit x dx over e 3x plus 1 as approaches 0. And then substitute e power 0 over e power 0 3 times 0, 0. And then is equal to 1. E power 0, 1. 1 plus 1 is equal to 1 over 2. Answer is 1 over 2. Answer is 1 over 2. Okay, settle. Okay. If you check this one, no. E exponent. Okay, settle for this part. Okay, for number, this is the number 6. It is overall for number 6. Okay, settle for number 6. Number 7, if limit fx minus 7 over x minus 4 as x approaches 6 is equal to 3, find the limit fx as x approaches 6. So the info, take the info this one to find f function fx. So starting here, according to the property of the limit, okay, limit fx minus 7 over x minus 4 as x approaches 6 can be written like this. Limit fx minus 7 x approaches 6 over limit x minus 4 as x approaches 6. Okay, separate the numerator and denominator and find limit separately. Okay, and then here is in bracket. Okay, for denominator. Okay, for denominator. Okay, this limit you can substitute. Okay, so substitute the value here. 6 minus 4. Settle. For the numerator here also can be separated using the property of limit. The two terms can be separated. Find the limit separately. Okay, and then here is limit fx as x minus 6 as x approaches 6 minus limit 7 x approaches 6. Okay, so okay, simplify. Okay, this one is equal to, make sure it's equal to 3. This one is equal to 3. So it implies that is equal to 3. Implies that limit fx as x approaches 6 minus, okay, substitute to 7 because of constant 7, just write down 7. Okay, and 6 minus 4 is equal to 2 and multiply, so it's equal to 6. Okay, simplify. Limit fx as x approaches 6 is equal to 13. So the answer is 13. So this is the answer. Settle for number 7. Number 8, the function h is defined as, okay, x plus 2 over square root of x squared minus 4. Find all the asymptotes. Okay, so to find the asymptotes, first thing we need to find domain of h. Okay, then here is h. Okay, the function is x plus 2 over square root of x squared minus 4 or set x minus 4. So up here is polynomial, domain real numbers. So just consider the denominator. Okay, so a ratio, this one not equal to 0, then under square root, okay, more or greater than 0. So we can get actually x squared minus 4 more than 0. Only more than 0, not included 0. When included 0, x plus 2 over 0 is considered undefined. Okay, quadratic, factorize quadratic, and this is quadratic smiling face. Okay, and negative 2. The graph is above x. So this is the return of x. Okay, Okay, so the domain is here between from negative infinity to 2 not included, and from 2 to infinity. Okay, so this is the domain. Okay, and then if you transfer to interval, union 2 to infinity. So to find the asymptote, you need to consider when x that tends to negative infinity, when x approaches negative 2 from left, here, and when x approaches 2 from right, and when x tends to positive infinity. So you have 4 times to find limit. Okay, and so for tends to negative infinity and infinity, maybe it produce a horizontal. You find horizontal asymptote. Okay, for x is equal to negative 2 or 2, maybe so we can find vertical asymptote. So we need to find limit as x tends to negative infinity, negative 2 from left, 2 from right, and tends to positive infinity. Okay. Limit x plus 2 over third x squared minus 4. So for this one approaches, so later we factorize. C to manage x minus 2, x plus 2. Okay, so find limit as x approaches 2 from right, x plus 2 over third x minus 2, x plus 2. Okay, and then for limit x tends to negative infinity, okay, same function, this one is okay, okay. And then for limit x tends to positive infinity, x plus 2 over third x squared minus 4. Okay, substitute directly. Negative 2 plus 2 over negative 2 minus 2, negative 2 plus 2. Then here is 0 over negative 4, 0. When you get 0, you have to check. This one is negative 2 from left. So from left, problem 0, right? So negative 2 from left. Here, negative 2 from left. So here is negative 1, negative 3. So take one number, negative 2 from 0, negative 2.001. Okay, negative 2 on the left. So instead negative 2.001. Okay, so substitute negative 2.001 means more than 2. So the answer, suppose the answer is negative. 0 to negative. Here is negative to more negative times negative positive. Okay, so 0 negative over 0 positive. This one positive. So negative, 0 positive. So this is case indeterminate form. Okay, so you need to do something. But the given is like this, and the function is like this, the indeterminate form. Okay, must continue. What to do? Okay, limit x approaches negative 2 from left, x plus 2 over third squared minus 4. So we need to do something because of they are considered indeterminate form. Here, wholly over square root. This is square root. You cannot divide by with the x for third x squared because of this is just value. So try to times conjugate. Times the conjugate is, you cannot say that third x squared plus 4 is conjugate. No, this is one term. Try to do this. Okay, try to do this one as a conjugate. So the conjugate is now x minus 2 over x minus 2. Just try and error. Okay, and okay, simplify. Here is x squared minus 4. X squared minus 4 and x squared minus 4 x minus 2. Okay, try to factorize this one. Try to factorize. Not factorize, just write in this form. We're going to write, okay, in this form, okay, so that we can cancel this term. Okay, so limit x approaches negative 2 from left. So here is actually third x squared minus 4 times third x squared minus 4 over, okay, x squared minus 4 times negative x minus 2. Okay, so now we can, this one equal term and cancel. Okay, cancel, let me cancel, and then now, okay, so write down the simplest one. So x squared minus 4 over x minus 2. Try substitute. Then substitute. Try to get this one is actually 0 confirm positive. Why? Because of under, okay, test and factorize x minus 2 x plus 2, substitute and get 0 positive. And now substitute here over negative 2 minus 2. Okay, so now you get 0 over negative 4. That is equal, answer is 0. Okay, done for this part. And for x approaches 2 from right, first substitute 2 plus 2, 2 minus 2, 2 plus 2. So is 4 over, okay, this one is 0, 0, and then 4 over 0 is equal to infinity. Now check which infinity positive or negative. Okay, so 0 to 0 or 2 positive, 2 positive here, 2 positive. Okay, let's say 2 positive is 2.001. Okay, minus 2 more than this one more than this, negative 2 minus 2, and then get 0 positive. So actually this one positive, under square root positive. Just want to check here, okay, undefined, define, right? So 4 is positive, so it times to positive infinity. Okay, settle for this one. For this one, substitute, okay, infinity over infinity. Infinity over infinity considered indeterminate form and tends to negative infinity. So for polynomial, this is polynomial and third. Okay, so for poly you have to divide with the by x, and for third divide by x, third x squared negative. Okay, so limit x approaches or tends to negative infinity. Okay, divide by x, divide by third x squared negative, why negative? Because I need negative in negative. Okay, so simplify. Limit x tends to negative infinity. 1 plus 2 over x. Okay, minus 1 minus 4 over x squared. Then substitute the value. 1 plus 2 over infinity is equal to 0. Okay, 1 minus 0 is equal to negative 1. Settle for this part. Okay, and when x tends to positive infinity, same procedure. Okay, and then substitute directly infinity over infinity. This is polynomial over third. Okay, and then tends to infinity means that for poly divide by x, for third divide by third x squared positive. Okay, limit x plus 2 third x squared minus 4. Okay, divide by x, divide by positive. Why positive? This one positive. Okay, and then simplify. Limit Okay, 1 plus 2 over x. 1 plus minus 4 over x squared. Substitute value. 1 plus 0, 2 over infinity 0, 1 minus 0 is equal to 1. Settle. Okay, this one also settled, right? And check. Okay. This one value x, value for x. The final answer is value for y, and y. Okay. If we write transfer to same like point, this one negative 2. Okay, when x is equal to negative 2, y is equal to 0. Okay, so for this part, when x is equal to 2, y is equal to positive infinity. To positive infinity. Okay, and this one, when x tends to negative infinity, y negative 1. Okay, negative infinity, negative 1. And then this one, when x tends to positive infinity, y to 1. So positive infinity 1. Okay, so now this is value for x. Value for x. Value for y. Y. Okay, value for y. So once, okay, this one give, okay, one value and one infinity sign. One value, one infinity sign. One value, one infinity sign. So they also consider asymptote. So this one, this is also value y. Okay, x, y. It's on just a point. Okay, just a point. So not a asymptote. This one not asymptote. This one is x. Okay, so it's y and y. Okay, when one value and one infinity sign, one value, one infinity sign, one value, one infinity sign, if we can consider the value that this one is considered asymptote. Okay, so this is vertical asymptote, horizontal asymptote. So the asymptotes for these functions, okay, vertical asymptote, x is equal to 2, horizontal asymptote, y is equal to negative 1, and y is equal to 1. Only 3 asymptotes. Okay, it is cannot claim this is asymptote. This is just a point. Answer is this one. Ada answer. This B. This is B. Okay, done. This is graph for function x plus 2 over third x squared minus 4. As you can see here, when x, okay, x is equal to 2, okay, this is vertical asymptote. Right? When x is equal to 2. When x tends to positive infinity, okay, here, so y is equal to 1. This is 1. 1, 3, 4, 5, 1. So y equals 1 is horizontal asymptote. And when x tends to negative infinity, also produce horizontal asymptote. At y is equal to negative 1. Here y is equal to 1. Okay, and okay, when x approaches negative 2 from left, here negative 2 from left, so here actually the graph approaches 0. And this is empty circle. When x is equal to negative 2, the graph is the function is undefined. Okay, so no graph on the right hand side of negative 2. So yeah, you can see that from left of negative 2, the graph approaches 0. Okay, so that is the graph for this function. Number 9. Given a function g is continuous for all values x, find the value of k if g is defined as piecewise function. Okay, so find value k. From piecewise function, try to change to number line. Okay, so easier for you to check. This is domain value for x, and this is the function according to given domain. So this is number line. Okay, negative 2 to 2. Okay, so x, okay, between negative 2 here included, okay, because of square bracket here, square bracket included. So then circle, function is k x squared minus 12. When x not in this interval, means that empty circle, okay, from negative infinity up to negative 2 exclude, and from 2 to infinity, the function is square root set x squared minus 4. Okay, squared minus 4. Okay, so from the piecewise function, change to number line and check. The problem is here. You can check the problem at x is equal to negative 2 or x is equal to 2. Okay, let's say we choose this one. When x is equal to 2, you can consider when x is equal to negative 2 as well. Okay? And since that mentioned that g continuous, means g satisfy the three conditions of the continuity. So the first condition for continuity is first g at that point itself at 2. Okay, g of 2 is equal to something. So that g of 2 here, consider this point. 2 is then circle lies here, lies on the here, and then we choose the function. The function is k x squared minus 12. So x is equal to 2. Substitute. Okay, substitute. Simplify for k minus 12. Is one of the function we can see. Okay. The second step, find limit. Limit x approaches to, okay, since that this one define continuous. Okay, so you can take 2 from this one from left, from right. We choose the opposite function, that is this one. So why? Because of if we take 2 from left, we take the same function. So we take the different function. Okay, we don't want to take the same function as number when g is equal to 2. G of 2 is equal to something, or x is equal to 2. Okay, so choose the function is x squared minus 4 when x approaches 2 from right. Then substitute. And this is 2. Okay, simplify. 4 minus 4. 4 minus 4 is equal to 0. Okay, settle. Then the third step is step 2 equals step 1. Means that this one is equal to this. Okay, or okay, limit x approaches 2 from right, x squared minus 4 is equal to g. Okay, this one is 0. This one is equal to 4k minus 12. Then define 4k minus 12 is equal to 0. 4k is equal to 12. Therefore, k is equal to 3. Answer is 3. Okay, so that is 3. So then, or you can double check, find the value of k when x is equal to negative 2. Just follow the same procedure and still can get k is equal to 3. Okay. Okay, number 10. Use the definition of continuity to determine the values of p and q if f is continuous and x is equal to 4, where p, q are constants. given the function f is defined as this one. Okay, so this is piecewise function. Change to number line. Okay, remember this is x, domain, and this function coordinate domain. Okay, 4, 4, 6. So this is 4. X less than 4. Less. The function is this one. Squared plus x minus 20 over modulus x minus settle. Okay, and when x is equal to 4, or y is equal to p, this is just a point, 1 point. So this one, just 1 point, p, only p. And then when, okay, x lies between 4 and 6, 4 not included, to 6 included, function is 4x minus q, linear. Okay, and when x more than 6, greater than 6, the function is r, only r, constant. So from the piecewise functions, change to number line is easier for you to find to answer the question. Okay, so now we're going to find p and q, value p and q. And okay, study. So the problem is here, at x is equal to 4. Okay, or here, maybe here only involve q and r. For this one, involve p and q. We're going to find p and q. Okay, and let's discuss when x is equal to 4. Okay, so when x is equal to 4, we mentioned that f is continuous. Continuous means f satisfy the 3 conditions, the 3 steps. The first step is f of 4. Okay, so f of 4 at the point itself, from here, then circle here, or this one p, so it's equal to p. F of 4 is equal to p. Now we're going to find the second step. Okay, limit x approaches 4. Here x approaches 4 on the left, on the right. On the left is here, the function is this one, a different function. On the right also, this one different function. So we try to consider all. So since this on the right hand side, it consists of q, unknowns, so better for you to take this one on the left hand side. Why? Because of this one consider, we can find the value of p. Okay, so take the from negative, from the left. The function is x squared plus x minus 20 over modulus x minus 4. Okay, and direct substitute. Okay, here 4 16 plus 4 20, 20 minus 20 is 0. Okay, 4 minus 4 is 0. This is indeterminate form and involve modulus. You need to define modulus. So define modulus. Modulus x minus 4. Okay, define positive x minus 4, negative x minus 4. When x minus 4 more or equal 0, when x minus 4 less than 0, or x minus 4 when x more than 4, negative x minus 4 when x less than 4, or transfer to number line. Number line. Okay, actually x is equal to minus 4 is equal to 0, x is equal to 4, right? So here is 4. Okay, you just remember that when x minus, so to the right positive x minus 4, to the left negative x minus 4. Actually, without using this, you still can remember using the number line. Okay, when x positive, x minus 4, to the right positive, to the left negative. Okay, when 4 minus x, opposite, the opposite function. So now we're going to find 4 from left here. Okay, this function. So limit x approaches 4 from left, x squared plus x minus 20 over, take this one, negative x minus 4. And the function is this modulus x minus 4 change to negative x minus 4. Okay, according to definition. 4 from left. Okay, and again substitute. Still you get 0 over 0. And this one you have to polynomial, factorize. Factorize. Okay, so limit x approaches 4 from left, factorize x minus 4, x plus 5 over negative x minus 4. Okay, so okay, cancel this one, and okay, then write down this one. We get negative x plus 5, and substitute 4 plus 5 is equal to negative 9. So the answer is no, not complete yet. Why? Because our aim is to find value for P and Q. This is not the final answer. Okay, this is not the final answer. And okay, check. Oh, this is just second step. We're going to continue for the third step. Okay, still not complete, not finished. The third step. Okay, step 2 was step 1. Okay, step 2, limit x approaches 4 from left, fx is equal to f of 4. Number 1, f of 4 is equal to p. Okay, this one on the left hand side just now, find this one is equal to negative 9. Therefore, p is equal to negative 9. Settle one part. Okay, p equals negative 9. And now we're going to find q. Find q. Okay, still we consider when x is equal to 4. Because if you consider on the when x is equal to 6, okay, this one is r, unknown. We don't know the value. So better stick to the x when x is equal to 4 on the right hand side. Okay, still follow the 3 steps. See, like the first one to find p. Okay, follow the 3 steps. Now our aim is to find q. Okay, follow the 3 steps. First, okay, f of 4. Still when x is equal to, okay, consider at point x is equal to 4. First step, f of 4. F of 4, still p. F of 4, 4. Okay, then circle p. Still p. Okay, p of p is equal to negative 9. Okay, so the second step, limit. Okay, x approaches 4, and then check. Oh, according to number line, 4 positive. Yeah, and lies here on this line. So we choose 4x minus q. Okay, we're going to find q, right? Okay, so choose 4x minus q. Okay, 4x minus q. Okay, from right. Okay, then substitute here. 4 minus q is equal to 16 minus q. The third step, okay, number 2 equals number 1. Okay, since f continuous, okay, for all values of x, right? Okay, then okay, this one, limit x approaches 4 from right, fx is equal to f of 4. Okay, this one f of 4 is p. Okay, this one is 16 minus q. Okay, given p is equal to negative 9. Okay, here negative 9 p. Okay. Okay, then substitute negative 9. It implies that q is equal to 16 plus 9. Therefore, q is equal to 25. So, answer is p is equal to negative 9. Q is equal to 25. Okay. Then, so option negative 925. Negative 925. So this is the answer. So done.